Thank you, esteemed guests. The lighting of the lamp marks the beginning of knowledge, wisdom, and enlightenment. Next, I request everyone to kindly rise for the Delhi University Kulgeet.
सकल वसुधा निज कुटुंब की भावना संस्कृति सनातन आधुनिक शिक्षा पुरातन ज्ञान धारा का संगम निष्ठा कृति सत्यम मंगल दिव्य भावों का समागम जयति जय जय जयति जय जय ज्ञान का आलोक अनुपम भव्य महाविद्यालयों के परिसरों से चिर सुशोभित श्रेष्ठ गुरुजन कर रहे छात्र और छात्राएं पावन साधना संकल्प संयम डबल जयति जय जय जयति जय जय ज्ञान का आलोक अनुपम श्रेष्ठ सुंदर दिव्य दिल्ली विश्वविद्यालय विहंगम जयति जय जय जयति जय जय ज्ञान का आलोक अनुपम ज्ञान का आलोक अनुपम ज्ञान का आलोक अनुपम ज्ञान का आलोक अनुपम.
Thank you. Please be seated. It is now my pleasure to invite our esteemed principal, Professor Gyantosh Kumar Jha, to come forward and felicitate our distinguished guests. I request Professor Gyantosh Kumar Jha to present the planter, shawl and memento to Professor Praveen Chandra, Professor at USICT, IP University. Now again I request our principal to present planter, angvastra and memento to Professor B.B. Singh, who is a professor in School of Computers and System Sciences at Jawaharlal Nehru University. Now I invite Mr. Manvendra Yadav, who is the coordinator of the Computer Science Department for the Science Star College scheme. Computer Science is one of the 6 participating departments, to felicitate and welcome our principal, Professor Gyantosh Kumar Jha. Atmaram Sanatan Dharm College, affiliated with the University of Delhi, is a renowned institution dedicated to fostering academic excellence and holistic development. The college has earned the prestigious NAC Grade A++ with a score of 3.7 and has been ranked 7th at all India level by the National Institutional ranking framework, that is the NIRF, by the Ministry of Education. Our college continues to uphold a tradition of nurturing talent and promoting innovation and research. This event is organized under the banner of the DBT Star College Scheme, the Department of Biotechnology, Government of India. This initiative of the Star College Scheme was launched with the aim of strengthening undergraduate education in the fields of biotechnology, life sciences, and related areas. The main aim of the scheme is to popularize science among the UG students. One of the key objectives is to encourage undergraduate research, which plays a crucial role in fostering scientific curiosity and innovation. This focus on research contributed significantly to our college achieving the first rank in the NIRF rankings in the research parameter, which is the RPC parameter. The theme of today's workshop, Machine Learning for Inclusive Development, Shaping India's Future, is not just timely but essential. Machine learning is a powerful tool that can address a multitude of challenges facing our country, from healthcare to education and from environmental sustainability to economic development. It has the potential to bridge gaps and bring about inclusive growth. This workshop will explore how we can leverage machine learning to drive inclusive development and contribute to a brighter future for India. We are extremely honored to have with us two highly esteemed professors who are leading experts in their fields. Professor Praveen Chandra, a renowned professor at the University School of Information, Communication and Technology, Guru Gobind Singh Indraprasth University. His expertise in machine learning and technology is well acknowledged. And also Professor V.P. Singh, a professor at the School of Computer and System Sciences, Jawaharlal Nehru University. His extensive research in computer science and systems theory is highly respected. We are really grateful that Professor Praveen Chandra and Professor V.P. Singh have taken out their valuable time to be with us and impart their knowledge to us. At this point, I would like to invite our respected principal, Professor Gyantosh Kumar Jha, to deliver the formal vote of thanks for this session. His dynamism has led our college to such great heights. For the past few years, we have, in the NIRF rankings,
Thank you, Professor Gyantosh, honorable speakers and my friends, Professor Praveen Chandra and Professor V.V. Singh, Professor Vinita Tuli, Vice Principal of the college, Professor Dikshit, Senior Faculty, our coordinator for Star College Scheme for the Computer Science Department, Mr. Manvendra Yadav, Coordinator Mahesh, and other faculty members, and my dear students. It is a pleasure and an honor for me welcoming my friends in my own college. Praveen Chandra and I studied together in Tiruvallur College. When we were doing our graduation. He is a very renowned professor, academician, and he is a man of innovation, research. Professor V.V. Singh is also a good friend of mine. Earlier he was in Delhi University, now he is in JNU. And very fine human being, a kind person, very passionate. I am grateful to both of them that they have taken out their valuable time for this workshop and for this inaugural session. I am happy that under the aegis of IQAC of our college and DBT Star College scheme, the Computer Science Department of the college is organizing this 2 days work on very important and pertinent topic, machine learning for improvement, shaping India's future. And I hope that various professors and experts from various fields will address you. They will present their presentation also, and their knowledge and their depth insights on the topic will definitely give you a new light and how you can be expert of machine learning, artificial intelligence and quantum computing. I hope that participants will gain deep insights into machine learning, artificial intelligence and quantum computing with a focus on their interdisciplinary applications for addressing real-world challenges. In fact, these tools are to be used for the betterment of the society and for the real problem of the society. So how you are using or misusing these tools and how you are using these tools for your study, for your research, for your innovation or for the development of our society and for the inclusive growth of our country so that we can achieve the goal of Viksit Bharat. So with this motto, this workshop was planned and I hope that you will definitely spend 2 days time with experts and you will gain something which you cannot gain in your classroom. So once again, I express my gratitude, Praveen and Bahadur ji, for being with us and you both of you are always very kind and helpful for me. Whenever I ask Praveen for any kind of program and workshop, तो he tells me इसमें ना करने की गुंजाइश तो है नहीं, इसलिए अब तो मैं कुछ नहीं बोल सकता हूँ. So thank you so much, Praveen. Thank you for giving me the अधिकार. Right. Thank you.
Thank you, sir. Dr. Praveen Chandra is working as professor in the University School of Information, Communication and Technology at Guru Gobind Singh, Indraprasth University, Delhi. He began his teaching career as assistant professor at Lal Bahadur Shastri Institute of Management, New Delhi. He has also worked in University of Delhi as an associate professor during 2010-2011. He was assigned the responsibility of the controller of examinations of the Guru Gobind Singh Indraprasth University from July 2011 to July 2019. He was the Dean of the University School of Information, Communication and Technology of the GGSIP University from October 2020, September 2023. He did his MSc in Physics from the University of Delhi and MTech in Computer Applications from the Indian School of Mines, Dhanbad. His doctoral research work was in the area of feed-forward artificial neural networks. His teaching and research interests are in the areas of artificial neural network, software engineering, biometrics, specifically fingerprint analysis, and wireless sensor networks. He has more than 120 papers in journals and conferences to his credit. Once again, we welcome Sir, and I invite Professor Chandra to address the gathering. Presentation.
जियो टैग जियो टैग नो किसे बोल रहा है तू लेकर आ उसको बोल चेयर को हटाना
Everybody has left the dais. That means they have left the podium for me. I will not be very formal because most of you are students, right? So let me tell you one thing. Your principal did not tell me every bit of that statement. When I make the statement, I don't have an option. We studied together. Doesn't mean that we are in the same batch. He's my senior. I never have an option. You understand that? The senior है, कहाँ जाएंगे? कुछ कर नहीं सकते. So that's why, but that is not the only reason. He is also one of the nicest human beings that we had as a senior. Seniors are like everybody else. Some of them are good, some of them are bad, and some of them are downright ugly. He was one of my nicest. And the faculty here and the students. Now, last time I came to your college, I was told, refresher course, you have to take a lecture. The moment somebody says refresher course, take a lecture, it means teachers are there, off the field, make it heavy, put in mathematics, and when I came here, I saw only students. This time, I would have not more than 3 equations anywhere. What I'm going to speak on is something. By the way, can I ask you one question? Most all of you are science students, right? Anybody from a non-science background? A few. Okay. Anybody without any mathematics background? Nobody. Good. So, this is my, I'm going to speak on something called large language. Something that we use every day to cheat. स्टूडेंट ही तो हो असाइनमेंट करने के लिए
हाँ चेयर बढ़िया पीछे वहाँ बैठा
ठीक है अभी थोड़ी देर के बाद
नहीं देखिए
टीचर से क्वेश्चन पूछने के लिए
बैठ जाने कब तक पढ़ेगा इन तक नहीं रहा इसके
लार्ज लैंग्वेज मॉडल आर द करंट अपर लेवल
वहाँ से बैठ कर ले आराम से
or you can say most advanced models. I'm going to talk about. Specifically, these are the 5 questions I will be answering. First, we will do the good part, then the bad part, and then putting them in perspective. इतना बड़ा भी नहीं है. Now I'm using the Hindi word बड़ा in the sense of rigorous. It's not such a good. None of these models are never good by definition. So I'll tell you, in my opinion, what is a model. And model is nothing more than a simplistic approximation to reality. Which means, by definition, most of the time, it is incorrect. And if something is incorrect, never take it too seriously. Take it seriously. It gives you some information, but with a pinch of salt. Might not be correct. You understand this? With this, let's start. आपके लिए कोड लिख देता है. No, we only pick up Copilot, but remember, Copilots exist for almost all IDEs that we use. They exist even for Mathematica. Code completion was always there. Now this is writing your code. Apparently, such a good thing eliminates the need for thinking. That's what everybody tells me. तो सोचने की जरूरत नहीं है. कर देगा. Believe me, as a teacher, I have a problem. If the students don't think, who thinks after 20 years? Who thinks about writing these codes? Who thinks about writing these co-pilots? Nobody. That is the limit. By the way, I hope you understand. Generates bulk, boilerplate, unit test, and eventful functions. That means it does everything for you. Most of the time correctly. That is a statement that I will be repeating. Most of the time correctly. Companies के लिए lesser people are required. People become more efficient. I have not written something there, and it makes people dull. It de-sharpens your brain. It does not require you to think. You understand that? Reduces time on repetitive tasks. Good enough. Allowing focus on problem solving. But if you are not solving the problems, how will you focus on the problems? How do you learn to solve problems? By solving problems, not by taking solutions. So mind is going to be sort of a negative position, not a positive. Positive, everybody will talk. But you have to be, every technology is a true SO. You have to understand when not to use it. So I would suggest, whatever you are doing using these tools, don't use it for the next 5 years. After that, feel free. Doesn't work. It can autonomously design, give the requirement specification, it can give you a complete solution. The catch is, if you provide a complete, well-defined specification, that is a catch. Those of you who have ever written more than 10,000 lines of code, if you have, you will understand this. Writing the requirements in such a manner that it should not be changed by your implementing it. This is not easy. It can do this. It can do this very well. Give a set of documents to summarize. Now the technology is such that the summarization can be almost as if by a human. Again, remember that term, almost. Scientific breakthroughs, and they will give examples like this. Remember, somebody has to tell what to look for. The system doesn't do it automatically. And that is the requirement specification in place. You have to ask. It doesn't give. Just like that. Right? Somebody will tell you and come and tell you, it does autonomous discovery of knowledge without telling you the next part of that statement. Autonomous discovery of knowledge once what is to be discovered has been defined. Right? Just because you can walk away from your computer doesn't make it autonomous. You initiated the search. You defined what was you were looking for, and then it does the search. But it does accelerate research cycles. Even if I get 99.9% correct, it is a gain.
स्क्रीन तो
Right?
बता
Look,
दे
at your age, you are not looking at research papers
वीडियो
most
फोन
probably.
लाइव बंद करता था
But it is
अभी
a
तो नहीं हो रहा था पोर्ट्रेट में
taking
लैंडस्केप में
exercise.
चली
If you get into a topic, you want to look at the literature, first you download papers. In my time, in the last 10 to 15 years ago, go to the library, take printouts, take photocopies, read them, summarize them. Here it makes the job easier, finds out what are interesting, and almost always it will give you 99.9% accurate. So most of the literature is available to you. Right? You might miss a few, most of the time they will be slightly less important than the literature that it has obtained. Because this is one task where an approximate realization of the solution does not hamper your work. This is a good place to use it. But if somebody uses it for medical diagnostics, one of the most dangerous places to use it. Because there the reliability has to be 100%. Even 0.1 failure can be devastating. Understand that? So these are all the success stories that people talk, and then I'm going to give you a rebuttal. Why? There is a problem with this analysis. So I'm going to skip this because they have said 45 minutes. And I'm not going to only talk about ये अच्छा करता है, ये अच्छा करता है, लेकिन देखो ये क्या गड़बड़ करता है. That would be meaningless. But I hope I have set the tone. Works, helps, there is a catch. That's all. That is all you are supposed to remember. It is like any other tool that you have. It is not a panacea for all your learning. It is just a tool to be used, misused. Look, an expert is somebody who misuses it. A novice is a person who uses it. An expert
साइड
knows
से बना ले
how
हो
to change
जाएगा
the.
साइड से बना ले, वो कह रहे हैं हम लोग खड़े हैं तो उन्हें आगे का नहीं दिख रहा पीछे,
तो वहाँ से बनानी पड़ेगी।
ठीक है?
वहीं से बना ले बैठे बैठने की
Skip
जगह।
this.
वहाँ से लगाओ।
LLMs are now transforming. The previous slides were nothing. Whatever areas that I could think of, in 4 headings, I divided. 2 lines for this, 2 lines for this, 2 lines for this. There are thousands of places where this can be used. And you hear statements like this. LLMs are now transforming industries from software engineering to medicine, science, and the arts. Think of any field. It's being used. The real wow is not just code generation, it is the cross-domain impact reshaping how humans work, create, and communicate. Now tell me, this was true for steam engines. This was true for every technology that we have developed. Every technology has an impact on human life. No technology that we have ever developed has solved all our problems. Correct, but at every time when the steam engine was developed, people thought, done, हो गया, सारे problems solved. 1800 something से लेकर के आज तक हर बार यही होता है. कुछ भी नया होता है, बस हो गया. जिस समय हो रहा होता है, while the technology is being developed, euphoria is very good. सब खुश हैं. जिधर देखो किसी की लाइफ दौड़ रही है, कुछ कर रहा है, कोई कुछ कर रहा है, देखो LLM से ये हो जाता है, LLM से वो हो जाता है, सब चीज हो जाता है. It's just a tool. And like every tool, it has its limitations. So today we are going to talk about how it works. Why it works, not at a very mathematical general idea. Somewhere towards the end, I will give you, using one framework, how to develop a LLM, an idea of that. Right? And then a long lecture on what are these problems. Remember, for every tool, even when you are being taught, have you seen that? When to use a tool, when not to use a tool, what are the advantages, and most importantly, what are the disadvantages. Right? That constrains the uses of the tool. For this tool also, you need to understand that. Remember, there is no magic. In fact, what it uses is addition, subtraction, multiplication, division, and a paradigm of communication. Now, some of you are in the 2nd or the 3rd year. I hope that you have seen something like a Fourier transform and the butterfly diagram. If you have seen that, That is the diagram of computation that is being followed almost everywhere. And if somebody among you is a, I have no idea, only computer science, electronic students are also here? None. Ask them if there are electronic students in your college. If they have heard of control theory, they would have heard of feedback control loop. That is the training mechanism, nothing more. So no new thing. People come and tell you, नया है, सब चीज नया है इसमें. And I haven't seen anything new being developed after 1995, except the machines that are available. The machines you generally phase out in 5 years. And the government says the depreciation is 20% per year. 5 years you replace the machine. The machines become bigger, the machines become more powerful. Techniques, all mathematics, everything was developed prior to 1995. Somebody comes and tell you Hinton developed deep belief networks in the 2010s. Forget it. Hinton did not write a newspaper, but there is a reference more than that. Somebody tells you, no, they were using bounded activation functions. It was Hinton who came up with the rectified linear unit. Forget it. 92, it was already done. Just because somebody doesn't give a reference to another paper and then people look at only one paper, because nobody looks at, look, the attention span of researchers has decreased in time. Even I have seen that. At one time you used to see exhaustive referencing as far as in the back. Now nobody gives references for more than 3 years old papers. There is a whole history behind it, why that is being done, impact factor, blah, blah, blah. Right? But the drawback is, most of the things are being rediscovered. 1998, convolutional networks. 1970s, Fukushima was already using convolutional networks. So nothing new. There is not a iota new in these techniques. And now we can discuss what is the technique. The only thing is availability of libraries, availability of coding tools, and availability of more powerful machines. The first machine that I built in 1998 was a 100 megahertz machine. I have got a 5.3 gigahertz machine that had one core. It was a 386TX2. Okay. I have got a machine now, and that is old. It's 6 years old, so it has to be effectively. It was not my personal machine, it would have been thrown away. It has 32 cores. Now, that is the amount of power that we are talking about. So look at this. An LLM is a very large neural network. I will not talk about neural networks per se, just think of this. It's nothing more than a sort of a linear computational device where the computation flows like this. And it's an adaptive machine. Just like a control feedback loop, you adapt the parameters of the machine so that the inputs and the outputs match. Very simple. Right? इसी तरह की चीज है, आप इधर से कुछ डेटा डालते हैं, कुछ वैल्यू आता है, चेक एरर है क्या, एरर है, इनको चेंज कर दो. जो बीच में कंप्यूटेशन में यूज हो रहा है उनको एडजस्ट करो, एडजस्ट करने का एक तरीका होता है. दैट इज नोन एज द ट्रेनिंग एल्गोरिथम. सो जस्ट a neural network. To do one fundamental thing, predict the next token in a sequence. Now I use the word sequence. So which means there is a set of tokens which are coming. भाषा क्या है? When I am speaking one word at a time. Each of these words are tokens. Now, an LLM, if I speak 5 words, it should be able to predict what is going to be the 6th word, and so on and so forth, based on the knowledge of the language that it has. If it has additional information about the subject that I am talking about, better. Its accuracy will be better. And as we grow the corpus of knowledge embedded into the neural network, it will have higher and higher reliability, prediction power. Its accuracy will tend towards 1, never reach 1. And understand, the problem is never reach 1. So this means that the model learns the probability distribution over the vocabulary V for the next token X is given all previous tokens up to t minus 1. 1 से start करके t minus 1 तक के टोकन आ गए आपके, बताओ अगला क्या है? छोटी सी प्रॉब्लम. You have been solving these problems with numbers. Given the sequence 1, 3, 5, 7, everybody knows the next would be 9. Right? You are looking at the pattern, finding out its, in a sense, the recurrence relation, and giving the next element. Here it does it in a probabilistic manner. The probability of this word or this sequence element occurring is this much. And then you take the majority voting out of that. Whichever has the highest probability is most probably the element that should have been predicted. So it is probably always correct. Remember, now we have a probabilistic model. It is not a deterministic model. By repeatedly applying this prediction, the model can generate coherent text, answer questions, write code, and even reason over sequences. That is all. तो बड़ा रॉकेट साइंस नहीं है, मैथमेटिक्स थोड़ा डिफिकल्ट है, प्रॉब्लम पोजिंग बहुत सिंपल. And when I say the mathematics is difficult, not more than UG level, unless you get into its approximation capabilities and things like those, where you need graduate level knowledge of mathematics, linear algebra, differentiation, you are good to go. Which means matrices and differentiation, you are good to go. You don't need much more than that. And obviously, understanding of the triangle property and things like those will be helpful. Triangle property, you remember? Sum of the two sides of a triangle is always greater than the third one, unless the points are collinear, then it's equal to. Agreed? So let's look at this again. It says an LLM predicts the next token in the sequence by estimating a probability distribution over the vocabulary V. So in normal probability parlance, it would mean as a conditional probability. We know that the elements x1 to xt1 minus t minus 1 have occurred. What is the probability that a particular xt would occur? So it does conditional probability assessment. Remember your Bayes theorem. In a sense, it is trying to compute the conditional probability using or embedding the Bayes probabilities, the posterior probability and posterior prior probability inside its structure. Estimating these two probabilities from the data itself. That means you input a sequence x1 to t1, t minus 1. Model produces logits zt belonging to R to the power mod V. Just think of it. It is a V-dimensional real space. Okay? Logits are nothing more than a value that is obtained between 0 and 1. Softmax converts logits into probabilities like this. So that is a function. These are the functions that you will see when you are trying to implement any neural network. This probabilities as we have solved. This gives you the probability. The ZT are the, in a sense, the values being calculated. Okay? The token with the highest probability is selected or sampled as the next token. Sampled is the word that these people use as highest probability is said to be sampled because there are other tokens possible. Visual illustration is the cat, sat, LLM, softmax, predicted text. Token is right. This is how it will behave, one after the other, and it will keep on producing. Which means whatever is the current output joins back as a part of the sequence to feed in as the most recent input. You understand? So this chain can keep on growing. If you have, let's say, you are using a window of, let's say, 512 words, Then every time 512 words are to be presented to this network, one output comes, the leading seek element is dropped off, the sequence generated, the token generated is added at the end, and then the next word is generated. कहानी लिखना है, simple. This I have already said. Look, these are the terms that you will see. Tokens, they are embedding in a high dimensional R space, that is real space, as a number. Similar words are closer in the vector space. Distance. Closer means distance of some type or the other. Euclidean distance is not the only distance that you will see. There are infinite number of distances or matrices are there. Context window, the number of previous the tokens the model considers. That is what I said, 512. That is the value. Okay? Tokens are the ones in blue. Embedding are given in three-dimensional space. That means I am using this bit of encoding for this. Precisely speaking, I am using the numbers, real numbers, to encode my tokens. Okay? Dimension of D can be hundreds to thousands. So these require heavy amount of memory. So every token that you have might mean 1000 real numbers. Even at 14 points, or 4 byte 14 points, you are talking of 4000 for every token that you are talking about. And then you talk of, I gave you an example of 512. Large models are not 512 sequence size. They typically run into a few thousand, if not more. Sometimes even into millions tokens at a time. So effectively what is happening, somehow the computation will calculate a hidden state. It's a layered computation sort of. And every state is a hidden state because that is not being seen. Right? Computation input here, then something is calculated here, then something is calculated here. Now the output of these elements are called the hidden states. Because they don't effectively matter to you, but they actually are the computation. The last where you get the output is the one that you see. That is the prediction. These actually embed layer by layer the features that are being extracted from the data to give the prediction. It is these features which are mixed up by the model to give you the actual answer. So the timeline is, this is how things were developed. 50s and 60s rule-based n-gram models, 70s and early 80s, RNNs, late 80s and early 90s, LSTM and GRU. These start coming from 2005 onward. Right. Transformers, accurately speaking, 2017. Right? This is a change. This is a change how, if you are talking of large language models currently, this is how they create. How the smaller models get converted into larger models by identifying the limitations of these models. Where will this end? Till I am alive, I will be seeing that. Till you are alive, you will be seeing that. My prediction never ends. Because all are approximating models. You will be making models are better, never reaching the probability of one. Right? You can read them up. I am not going to go into too much of detail. Three neural NLPs, rule-based and n-grams. The cat sat on. Now, this is the 3 grams. The cat the cat sat. So it's a 4 gram because n minus 1 value used to predict the nth value is a n gram. So 3 inputs predicts on. Rule-based systems, manually crafted rules for language parsing is typically what linguistics department of any language department does. Typically they use rule-based. N-gram models, statistical models, ranging from Markov chain, hidden Markov chain, and things like those. Now you have neural models also using N-gram model. But the limitations are cannot capture long-range dependency. That means if I use the first 3 to predict the 4, then I use the next 3 up to cat, sat and on to predict the, and if I keep on doing that, very soon my errors will start widening out. You can't use it for long-term prediction. Time series forecasting, the same problem will happen. Short-term forecasting, these methods can be used. Long-term forecasting for time series, you can't. Then they said, कोई बात नहीं, let's put them in a loop. Recurrent neural networks. Recurrent neural network means the intermediate values and the final values may be fed inside as the network to compute the next stage. Better. Long sequences suffer from vanishing exploding gradients. Now that happens irrespective of if you are using a bounded function in your system or you are using an unbounded. Bounded function, your training will in a sense stop because of gradients of variation. Unbounded function, you have infinities and then nans will creep into your computation. Not a number will creep into your computation because of the numbers becoming too large to be handled by the computer. So these are some of the problems. There are methods to solve them. Somebody will tell you regularization, this, that. That's it. Next generation, LSTM, gated recurrent units, they are equivalent. GRUs and LSTM are exactly equivalent in computational power. There is no difference. They are two different ways of doing the same computation. They have the same power as a recurrent neural network, but they do not suffer generally from vanishing gradient or exploding gradient problems. The computational probability power is same as a recurrent neural network, provided you are able to train. Please understand, a Turing machine can be simulated on a recurrent neural network and vice versa, which means these are the highest powered machines that we can make. Understand this? Some of you must have studied theory of computation by now. Those are your most powerful machines. A recurrent neural network can simulate a Turing machine, and a Turing machine can simulate a recurrent neural network, so their powers are equal. This is a result which was obtained in the 80s. Nothing. But these are sequential. एक के बाद एक के बाद एक के बाद करते जाओ. So to compute the representation of the tth word, you must process all previous t minus 1 words. This makes, and in a linear fashion. एक करो, दूसरे को process करो, तीसरे को process करो, जो result आएगा, combine them. This makes the processing slow. 2017, the Google team did one good thing. They came in with their architecture different to these, but parallelized. It's in parallel. Right? And that is known as a transformer. Nothing else. Its computation power is same as recurrent neural network, LSTM, GRU. So these, in a sense, are the machines that we can. I gave the name, कुछ तो हमारा भी है इसमें, of one of the authors, the other authors I don't know. Right? Remember, Vaswani is no longer Indian citizen. So he's an Indian origin person. But then somebody coming from archaeology will come and tell you all of us are Africans. Right? Because mankind started its journey from there. उसी तरह से ये इंडियन है, बट देख बोलने में तो अच्छा ही लगता है, देखो वासवानी, ठीक है, उसके अलावा कुछ नहीं. There is nothing that we have to cover. But these people did one thing. They Google by this time, from 2005, there is a consortium being formed as a cartel, and that is apparent. Google with the money, Nvidia with its parallel GPU technology, and Hinton and his PhD scholars and his postdoc scholars as supplying the brain. They developed, otherwise if you remember 2005, if you go and look at the sales data, GPU sales of AMD were higher than Nvidia. Technology wise, even right now I feel, if I can handle the GPU directly, which fortunately enough I feel that I am capable of, but I find that most of the people don't know how to program the GPU directly. Most of them rely on libraries. Nvidia, Google and Hinton, they gave them the libraries, and Nvidia became a bigger company. That is all. So that is the cartelization. Together with that, using the information from Nvidia about GPUs, Google developed a processing unit called tensor processing units. Look, GPUs work with two-dimensional matrices. Right? Nvidia also inbuilt TPUs, but small number of them in its GPUs for 3 and higher dimensional matrices. Google developed TPUs proper as a processing device. That they are. That is a pure parallel structure. Simple cores, thousands and thousands of those cores working in parallel for simple things. Linear algebra is one of the simplest mathematics. When you talk of matrices of 2 or 3 or 5 dimensions, they are simple objects. May not be that easy to visualize, but mathematically they are simple. So simple devices, every core is less powerful than the core that exists in the microprocessor, but it can do that work. So based on that, for that machine, they parallelized GRUs, and that became a transformer network. But we are engineers. These people are engineers. So they don't use mathematical terms, they give human terms. Like neural networks is nothing more than, in statistics, ridge regression, projection pursuit regression. हमने नाम दे दिया न्यूरल नेटवर्क. यहाँ भी कंप्यूटेशन का ह्यूमन नाम तो देना था. It is called attention. You are looking at all the words together, trying to understand their meaning. अरे पैरेलल में है, कौन देख रहा है उसे? कंप्यूटर can't see. It only processes. It calculates the next step based on the rules that have been embedded in the program. Anthropomorphic analysis of computers or its programming leads to a major issue. We have terms like intelligence, learning. No, nothing is learned. Understand it? It doesn't learn. You program it to adapt its parameters. They are two different entirely things. It is not an autonomous learning machine. So again, 3 values they define: Q, K, V. Query key value. What am I looking for? What I contain? What I provide if you attend to me? And you have these 6 tokens in the sequence. Each of them have 3 embeddings. Rather than 1 embedding, now we have 3 keys. And this is how it works. Q, K, V values. Robot has 3 tuples. A tuple with 3 elements. Everything has 3. All that is given to this attention matrix calculation, which calculates the softmax function of all this. QK transpose divided by under QK. This is how they define it. And then it outputs a set of vectors, which is in this case of dimensions. ये है भाई और कुछ नहीं, वो ज़्यादा complicated तो नहीं, provided you get these calculations as a library. They are easy. Writing those libraries is difficult, but the libraries have been made available. So if you want to use these models, you just need to understand the library and have an understanding of what these models do. That is what is happening. Parallel thinking. नहीं होता है. Have you examined how you read? Very few of you would be reading word by word. You would be reading multiple words at the same time, and your brain would be imputing words as you are reading. You read ahead always. Effectively, all these models are trying to do the same as a programming model. विश्वास नहीं होता है. Even with 50% misprinting in a text, you can read the text. Try to do that. Check it out. You will be able to fill in the blanks. But if you, when you look, and sometimes you will not even notice that there are mistakes. All that is here. Because in a similar fashion, that has been done here. And therefore, transformers have no recurrence. That means there is no feedback of information in a loop. It is one flow. Obviously, training will occur. That is a training mechanism would have a feedback. But calculation itself doesn't have a feedback. Okay? In a sense, it is unrolling the loop of feedback by making it a parallel step. Inject position information using positional encoding added to the embedding. So जो पहले हम embedding raw encoding कर रहे थे उसमें positional embedding भी होगा किस position में है. And typically sine and cosine functions of different frequencies are used. ये मैं इसलिए लिखा Fourier expansion नहीं आएगा. चाहे कुछ भी कर लीजिए मैथमेटिक्स वालों का आसानी से है और ये भी सच्चाई है. Chebyshev basis can be used for the expansion of any function in Hilbert space, and that's what that phrase was mathematical. Nothing. Right? And it's the simplest one to manipulate on a computer. So this is the structure. This is how it works. Token embedding plus positional encoding, multi-head attention, residual plus layer now, feed-forward network, residual plus layer now, final. You might have more than one of these. Depends on how large a network you want to create. Every place where you have a residual plus layer now, please understand, that is one unit of calculation. There may be multiple layers in that unit, but you have them in groups. Every unit, which is, suppose this is the first unit, let's say this extracts in a sense a set of features for the data that you have. The next one will mix it up and give you higher order features. And depending on what is the complexity of your problem that you are solving, you might require more than one of these layers to actually do the computation. And that diagram is being explained here. Right? GPT-3 has 96 layers, 4 obviously has much more, 5 has obviously has much more. Right? And when I say layer, it is that unit that I am talking about. Embedding up to computation. And the learning process is pre-training, general language knowledge. Task is not yet defined, but the language that is to be used, you have to embed in the system. Then supervised fine tuning. What type of questions might be asked? What is the domain specific knowledge that you want to embed? That must be completed. And once that is done, you are ready with real life with human feedback aligned with human values. That is the last stage. Okay? If you are not going to embed that specific function yourself, not embed, implement, you are going to use only a set of library tools. This is your problem. If you are going to implement the libraries, mathematics is your problem. Right? Choose one side. This application should be done by, let's suppose, I want to develop a model for finance. I have never studied finance. I would be the worst person to implement this. Unfortunately, right now, that job, if I was doing my BTech, I was in the third year, maybe fourth year, that job would have been offered to me. Ideally, it should be offered to a BCom student who has been taught how to use these models. They will understand, they will use it. If you don't understand this example, take it like this. Go and talk to your parents who file their income tax themselves. Recently they must have filed it. Ask them, कितनी गाली निकाले सरकार को? वो सरकार को गाली नहीं है. वो जो इंटरफेस है, वो कंप्यूटर साइंस के स्टूडेंट का बनाया हुआ है, जिनको टैक्सेशन के बारे में आयोटा भी नहीं पता. Without domain knowledge, developing a software is the worst thing that can be done. It is being done. Very few companies recruit people with domain knowledge. And that is why larger companies, greater companies say, work in that field, get the knowledge, then come to us after 3 years of experience. शुरू में ट्रेनिंग नहीं देंगे. Pre-training. Now this goes into the detail, and I am finding people are walking out, so I will come to the direct. Please, clear. Pre-training, I have already talked about this. Supervised fine-tuning, reinforcement learning. Reinforcement learning, you understand, only give a feedback, right or wrong. You don't worry about how much is the deviation from the truth. This was the thing happening. मुझे टेबल बॉक्स का साइज सेम रखना था and I was not able to fit. There are many more there. There are many more here. Right. So the 3 bigger ones that I find those models. Again, place is a place, a site, confinement. Right. Beta, and that llama should have been L small a M A. Okay, Mistral. So these are open models. That is a closed model. You only get an API access there. You get everything, right? And all this you will get in multiple languages, but one language would be there right now, and that is Python. Okay. And we'll also understand it. Easy to use, cutting edge, requires infrastructure expertise. वो आसान है, ये डिफिकल्ट है, बट इसमें आप कुछ भी कर सकते हैं, उसमें वही कर सकते हैं जो वो अलग है. Their internals are. So if you only want to develop an application, go there. If you are willing to pay. If you want to do research in this area and you want a framework, go here. So I'm going to give you an example using Meta, how to set up the toolchain. कैसे कैसे काम करोगे. करना तो यही सब है. Prompt engineering. सबसे पहले तो बताओगे ना कैसे ट्रेनिंग करेंगे. Now retrieval augmented generation gives you better data. What is that? You read up yourself. ये स्लाइड मुझे हटा ही देना चाहिए था, लेकिन लिख दिया था तो मैं क्यों हटा? So these are the steps that you use. और ये देखो, ये काम ये भी करता है. कोड इस लैंग्वेज में है, कोड इस लैंग्वेज में. तो जब चोरी करना हो असाइनमेंट के लिए, टाइम कम मिले, और सेम प्रॉब्लम C++ में दे रखा है, जावा में भी दे रखा है, बताए के लिए टेंशन. एक में कहीं से जनरेट कराओ और फिर ट्रांसलेट कराओ, और उसके बाद उसको समझ भी लो. लास्ट वाला फेज कोई नहीं कर रहा. आई एम फाइंडिंग स्टूडेंट्स डोंट डू दैट. फिर पहले भी तो किताब में कोड लिखा ही हुआ था. ऐसा तो कोई कोड नहीं पढ़ाया जाता, ऐसा तो कोई काम नहीं कराया जाता क्लास में जो किताब में. एवरीथिंग इज अवेलेबल इन द बुक. You find it hard to read the books? Then great. I don't care. Most of the teachers won't care, provided you read and understand what you are called. Unfortunately, good books will always, not almost always, these may not be correct. तो इनको असल में तो यूज करने वाले वही होने चाहिए जिनको करेक्ट रिजल्ट पता है, ताकि वो चेक कर ले कि रिजल्ट ठीक आया नहीं है. You understand this problem? These tools are not meant for novices. Novices are using it, experts are using it. These tools are meant to help experts. Give you a solution, you examine it whether it is a good solution. Right? This is about गामा. कहाँ से आया, कैसे आया, कैसे काम करोगे. And I am going to read this here because it's already copied here. Feel free to go through this and build up from it. I have also given you some bit of code how to write those sections, how to do it. Remember, Python is such a good language. It was never meant for programming. It was actually meant for Unix system administration. Quick and dirty coding. If you have ever done Unix shell programming, you will understand. लिखना होगा. ठीक है. So some people, some young people in the age group of 26 to 32 in 90s were maintaining Unix system. They had a issue. अरे इतना लिखवाता है. Why not write our own language? अभी तो ऐसा language बन के आया where the indentation defines how the code flows. It's such a bad language. It was never meant for this. It was never meant for writing 10 lines of code. And now we are using it for writing. Apparently, okay. The problem is we are not using it. Tell me one library of Python that is written in Python. There is none. So if you can't write the libraries in the same language, it is a library-based language. It's just connecting up like libraries. And those libraries are still being written in Fortran, C, C++, assembly to some extent. Most of the time the assembly would be embedded inside a C or C++ code, but sometimes standalone assembly. And that is it. The languages are still those. And corresponding to Python, there are thousands of languages giving you the same features. It happens to be the most fashionable one right now. 5 years ago, 7 years ago, R था, उसके 2 दिन पहले लिया आया था. तो हर 3-4 साल में तो फैशन बदलता है. इसका भी फैशन चला गया. This is the summary. This is how you do it. I've already given you the chain. This is your texture. Problem. It hallucinates. कुछ नहीं, गलती करता है उसका नाम. It predicts wrongly. And we give it a human name. It's hallucination. Right? bias because your training was improper. So now we are doing as if it is a human being. It's not a human being. Your modeling was bad. All this is going to happen. And they have equivalent statistical names. ह्यूमन नाम देने से इंटेलिजेंस नहीं हो जाता, ये याद रखना. It can be used for this. I can write a large language model and make it slant towards one orientation. That means slant away from another. I can always do that. The model will not be a problem. The problem is the person using it. So when people talk about if AI is used to generate a work of art, does the AI own the art? There is no meaning in my opinion. Whosoever use that tool is responsible for whatever they have created. This is not a human being that it can be held responsible for its own action. It's just a piece of code written by somebody, modified by somebody else. That's it. जो यूजर है मरना तो वो चाहिए ना. That is going to happen. Every technological tool, any new development is a big disruptive element. It changes society. Run-of-the-mill programmers will no longer be required. Standard algorithms, nobody needs any programmer to encode them. Because these tools will make zero mistakes because they are going to pick it up from the corporation. No mistakes there. टेक्स्ट के टेक्स्ट बुक डाल दीजिए इसमें, उसमें सॉल्व है वो तो आंसर सही देगा, अनसॉल्व है उसमें तो गलती करेगा. And 99% of programming is using existing code. So why do I need run-of-the-mill programmers? That is the major disruption that will occur. Another disruption that will happen, my prediction, you might see it, I might be wrong, I might be right. All predictions का अलग intact है. 10 साल के अंदर डेटा साइंस डिसअपियर कर जाएगा. ये डेटा साइंस कभी था नहीं. Statistics था, statistics है. You ask somebody what is the meaning of the term statistics, they will tell you it is the science of data analysis. So why have it in a new name? नया नाम देते काम नहीं बदलता, और जिसका काम होता है काम उसी को करना चाहिए. आज हम कंप्यूटर साइंस वाले उछल रहे हैं, ये डेटा साइंस है हमारा है, ये एआई के नाम पे सारे स्टैटिस्टिकल मॉडल हमारे हैं. कल नहीं होगा, उनको ज़्यादा समझ में आता है, और उनके पास एक उनका कज़न है इकोनॉमिक्स वाला, थोड़ा सा दूर थर्ड कज़न है ओआर वाला, इनका फील्ड. और स्टैटिस्टिक्स और मैथमेटिक्स तो दे आर कंजॉइंट ट्विन्स, और आधा तो शरीर जुड़ा ही हुआ है उनका. ये उनका फील्ड है, हमसे प्रोग्रामिंग कर सकते हैं, हमारे क्वेश्चन ही अलग थे और हमने इस फील्ड के सारे क्वेश्चन सॉल्व कर रखे. यू आर ऑल कंप्यूटर साइंस स्टूडेंट्स, डू यू नो व्हाट इज योर बेसिक क्वेश्चन? राइट ऑफ, because all of you want to become programmers. Your basic questions are not of programming. That is a tool that you use to do your job. Your questions are, what can be computed? How fast can it be computed? Can this problem have a solution? If it doesn't have a solution, can I approximate it? If it does not have a solution, can I approximate it? If I can approximate it, how good is that approximation? How do I obtain these solutions? These are your questions. Not how to write a program to train a neural network. That is for anybody and everybody who needs to solve a problem. So let's look at some of the information that I have compiled for you. ये सब तो होगा. तब environmental impact of training massive models, कंप्यूटर चलाओगे, एनर्जी heat generate करेगा. Computers now generate heat in such a large amount for massive clusters. This density of ACs won't work. And obviously this quality of ACs won't work. Right? So cooling के लिए पैसे लगेंगे. Heat is always a wastage. Right? Efficiency हमारी energy conversion की मुश्किल से 15%. टेक्नोलॉजी को डेवलप भी करेगा बट इम्पैक्ट तो लगेगा. ये सब चीज होंगे और ये होंगे. The more of these things are done, the more the general users will have an access to the tool which is right now restricted to the particular community. That exclusiveness will be lost. And when it is available to the people who actually need these technologies to solve their problems, your need for solving those problems for them would vanish. So prepare for that. Go to your core areas, learn your core areas, because that gives you the capability of learning anything else. Now let's talk about this. Training a neural network involves finding optimal parameters theta to minimize the lossless. Well, there is a loss function. Finding the global optimum for neural network weights is NP hard. Now forget it for a full network. Loading the weights of one hidden node is NP hard. Was proven by one of the persons whose textbook you are reading every time you are studying algorithms. Rivest is the author of that paper. 87, 86. NP hard है ये. यानी solution exponential time में होगा तो होगा, नहीं तो नहीं होगा. Which means you will end up only by finding approximation solution. Approximation leads to all sort of problems in real life. Some places approximations can be tolerated, some places it cannot. Never use these techniques other than as guiding principles for places or solving problems where exact solution is required. Use it as a guide. देखो सीधी सी बात है, भाई डॉक्टरों ने बड़ा अच्छा कर रखा है कि उनके पैथोलॉजी लैब्स होते हैं, एमडी करके डीएम करके बैठते हैं लोग. बड़ा डॉक्टर होता है जो वहाँ बैठता है. एमबीबीएस तो कर ही नहीं सकता पैथोलॉजी लैब में, उसको तो एमडी होना ही है पैथ में. वो सारा रिपोर्ट लिख देता है, सब चीज लिख देता है, उसके बाद एक लाइन लिख देता है कि इसको क्लिनिकली कोलैबोरेट करा लीजिएगा. मैं कोई स्टेटमेंट नहीं दे रहा, सारा चीज लिखने के बाद. ये जितने टूल जो भी आपको ओपन एक्सेस दे रहे हैं फॉर चैट जीपीटी हो गया, ये हो गया, पहले नहीं कर रहे थे. जब थोड़ा ज़्यादा बड़ा गड़बड़ हो गया, मैं तो वर्ड नहीं यूज़ करना चाहता हूँ, जब कुछ ज़्यादा गड़बड़ हो गई तो नीचे लिखना स्टार्ट कर दिया, वी कैन मेक मिस्टेक्स. अरे यू कैन नॉट मेक मिस्टेक, यू ऑलवेज मेक मिस्टेक, समटाइम्स यू मेक द करेक्ट थिंग. Please understand that. And most of the time you give a truth value near to the actual truth, never the actual truth. If the probability of being totally incorrect is 0, the probability of being totally correct is also almost 0. दोनों साइड से 0 है. ये तो है implication, consequence. The solution may not be globally optimal. Training depends heavily on visualization, architecture, and these are the problems that you face while using these techniques. और कंप्यूटर साइंस का कौन सा स्टूडेंट है जो फंक्शन अप्रोक्सीमेशन थ्योरी पढ़ता है? अरे मैथमेटिक्स वाले तो एमएससी तक ठीक से पढ़ते हैं. कंप्यूटर साइंस वाला कौन? तो है तो मैथमेटिकली यही. That means if you don't know the techniques of doing something and you are trying to do something, you understand what will happen, and it does happen. दिखता ठीक है, होगा नहीं। The more the complex the problem, the more are the chances of this happening. These are the problems. Overtraining जिसे करते हैं, generation leader ठीक रहेगा, और these are problems. अच्छा लगता है इनको सॉल्व करना, बट ये आपको पता तो होना चाहिए जो टेक्निक आप यूज कर रहे हैं किसी रियल लाइफ प्रॉब्लम को सॉल्व करने के लिए, उसके इश्यूज क्या हैं, when to use it, how to use it. I'm not saying that these techniques are bad. Please understand, these techniques are good. Just need to know when to use them and when not. Any questions? I can understand. If I can send half the class away, that means the topic was not enough. I also understand 50% of you are tired. I hope at least 1/3 of the class was interested in it. And that is true for teachers as well as students. Because everybody sitting on that side isn't it? If I'm sitting on that side, I was किसी को कुछ पूछना है, मैंने नेगेटिव कनोटेशन में बोला है, doesn't make my area of research. I am not denigrating my area. My problem is over glorification of this topic has happened in the last 10 years. As if सब चीज बदल देगा, दुनिया का सारा प्रॉब्लम सॉल्व कर देगा, बस यही तो है। क्या कहना है, यही तो है ये और स्टेटमेंट न्यूरल नेटवर्क के लिए। In the 40s, late 40s, von Neumann and Rosenblatt came up with the perceptual model. दुनिया को लगा कि सारा प्रॉब्लम है और साइंस वॉशिंगटन पोस्ट हेडलाइनें छाप रहे हैं, सारे प्रॉब्लम सॉल्व। एक बड़े आदमी को खड़ा होना पड़ा, मिल्सकी करके पढ़ा। MIT AI लैब्स का फाउंडिंग डायरेक्टर था, जिंदगी भर वो और पेपर साहब जिन्होंने किताब न्यूरल नेटवर्क को परसेप्टिव ज़्यादा में पॉपुलर था। So in 1957 they wrote a book called Percept and they said ठीक है कुछ करता है but it's same as the hill climbing algorithm, it has the same limitations, same issue, same problem, can't do much more than that, which means you find the local or local maxima depending on what you are trying to do. मिन्स्की साहब इतने बड़े आदमी, कैलमन साहब बाद ने जब इको सप्रेसर बनाया फॉर द ट्रांसअटलांटिक सबमरीन में, ये कहने के लिए कि जो बना रहा हूँ ना ये न्यूरल नेटवर्क, उन्हें बस बोला एक फिल्टर 80s में कैलमन फिल्टर नाम, 80 में 30 साल हो गए थे ना, रफली 30 years इज द 25 to 30 years इज द जनरेशन। एक जनरेशन गया, एक नया जनरेशन आता है 80s में, विमल हार्ट, हिंटन, लीगन, सेजनोवस्की, जितने बड़े नाम हैं, ये यंग लोगों का एक those of us who are old enough to understand that because we were young once, ज़्यादा सोचते नहीं, कुछ करते हैं, रिजल्ट आ जाता है तो हम बोलते हैं हमने ठीक किया है, पीछे कौन देख रहा है 20 साल पहले, they rediscovered everything। उसमें एक फिजिसिस्ट साहब थे, नोबेल प्राइज पहले ही ले चुके थे, हाफिज साहब, उन्होंने बोला ये सब नाटक कर रहे हैं, ये तो कुछ नहीं है, आइसिंग मॉडल है, हिस्टेरिसिस लूप, यू अंडरस्टैंड, फेरोमैग्नेटिज्म टू पैरामैग्नेटिज्म। उन्होंने बोला हाफिज मॉडल बनाया आइसिंग मॉडल के बेसिस पे, बोला जो हिस्टेरिसिस लूप है ना ये मेमोरी है, और एक पूरा ग्रुप घुस गया फिजिक्स वालों का जो खाली बैठे होंगे, डोंट टेक इट एज नेगेटिव कनोटेशन, खाली बैठे होंगे जिनके पास टाइम था, ये साइड बिजनेस ही तो था उनका, वो घुस गए काम कर दिया। एक इंसान अमित साहब हैं, डीके अमित, उन्होंने तो थ्योरी ऑफ ब्रेन किताब का ही नाम, द स्टैटिस्टिकल थ्योरी ऑफ ब्रेन, व्हिच इज नथिंग मोर देन अनसुपरवाइज्ड लर्निंग। There it is rediscovered everything that was discovered from 44 to 76. We rediscovered it. And everything that we are seeing right now was discovered by man. Nothing new has come after that. No new theoretical results. Except one result, which is 2014. How many convolutional layers are required in a signal minimally for it to work? And the answer is 4 hidden layers. Hidden convolutional layers. That is it. बाकी सब मायाजाल है, यूजफुल है, दूसरों को कंपेयर करने के लिए कितने को भाषा कर सकते हैं. हमें समझना चाहिए कि क्या करना है. There are open problems. There are thousands of problems. Right? Because we are always working with limited resources. Whatever we have been talking here, all inferences are based on an infinite resource model. Right? Actual problem is how to use finite resources to do it better. ठीक है? Thank you. If nobody has better. Data science will never get extinct, but remember, statistics always existed. Statistics is an older science than even computer science. Remember that. अरे राजा महाराजाओं को चाहिए था कि जनता से टैक्स कितना वसूलना है, कितने लोग जिंदा हैं, कितने को मर गए. स्टैटिस्टिक्स तब का है. Before hard sciences became hard science. अल्केमी से हार्ड साइंस बने, उससे पहले से स्टैटिस्टिक्स है. एंड स्टैटिस्टिक्स का डेफिनेशन क्या है? व्हाट इज द मीनिंग ऑफ द टर्म स्टैटिस्टिक्स? द साइंस ऑफ डेटा साइंस. नाम बदले हो, मैं बोल रहा वापस चला जाएगा, उन्हीं का है, उन्हीं के पास. बस ये याद रखना, डिसअपियर कभी नहीं करेगा. नथिंग डिसअपियर्स. देखो, try to understand it. The set of people sitting here would typically have 3 names. One their legal name, one given by their family members, and one given by their friends. Typically these 3 names would be distinct. There would be very few people with the same name. As a physics है, चले जाओ फिजिक्स ही बनाएगा. ठीक है? तो वो यूनिक बच्चा है जिसका नाम नहीं बदलता. मैथमेटिक्स का इतना विभाजन हो गया है. मैथमेटिक्स अलग, स्टैटिस्टिक्स अलग, एंड द टर्म आई यूज स्टैटिस्टिक्स एंड मैथमेटिक्स आर कंजॉइंट. अरे बोरल सेट पढ़ना है स्टैटिस्टिक्स स्टार्ट करने के लिए. विदाउट रियल एनालिसिस कहाँ से बोरल सेट पढ़ लोगे? राइट. तो उनका तो स्प्लिट हो गया. उनका तो हर बॉडी पार्ट को काट करके ऐसे से करा रहा है. फिजिक्स वाले भी कर रहे हैं.
यार अगली बार से ना वहाँ बैठो, हमारे सीट खा रहे हो.
Humankind, knowledge is humankind, then individuals must stand up. You can't make parts of it.
खड़े हैं तब से.
That is what is happening. Data science will never disappear. It was always there, always be. I am saying let's refer to statistics and call this statistical modeling technique applicable to us. Problem domain. It makes our life easier. It allows us to look at the rich literature that is available in statistics. Find out what has already been done. नहीं तो क्या होगा? तुम R square rediscover कर लेगा. अब बोलेगा goodness of fit. Whatever is your name, his name, goodness of fit. R square अपने initials का square बना लेगा. ऐसा तो होना नहीं चाहिए ना. But that happening. Bye. Thank you.
कितना बोल
नहीं करना, अभी करना है. बंद करना नहीं करना.
Thank you, sir, for giving us such an enlightening lecture on LLM.
हो गया.
Sir, your lecture was incredibly, I would say, engaging and informative. And you helped us to understand the technical depth, real-world applications, and ethical considerations around LLMs in a way that is both accessible and thought-provoking. Your ability to simplify complex concepts while also challenging us to think critically is truly commendable. Thank you once again, sir. and we hope to have opportunity to hear you again and again, as we most of us in our faculty members are your fan. So thank you very much, and I would now request for the next lecture to our guest of honor, Professor B.V. Singh. Professor Singh is currently working as professor in the School of Computer and System Sciences, Jawaharlal Nehru University. He received his MCA degree from MMM Engineering College, Gorakhpur, and PhD degree in software reliability from University of Delhi. He has published more than 100 research papers. His research interests include mining software repositories, empirical software engineering, and software reliability engineering. He has co-authored a book, Essentials of Computer Network Database and Internet Technology, from Narosa Publishing India. He has also received an award from Society for Reliability Engineering, Quality and Operations Management for contribution as a promising author and researcher in the field of computer science. He has completed research projects from University Grants Commission, Department of Science and Technology, Government of India, and University of Delhi. He is member of Society for Reliability Engineering, Quality and Operations Management and Association of Computing Machinery, ACM, and expert panel member of Ramanujam Fellowship, ANRF, Government of India. Sir will be speaking on software evolution, a machine learning approach. Sir, please.
So, thank you so much for inviting me. So, I will discuss some applications of machine learning in software engineering, and my previous speaker, Praveen sir, has very beautifully explained you the working of the code behind all these algorithms.
Please maintain silence. There should not be any mutual consultation. Please.
व्हाट्सएप से ये बोला तो नहीं कम
नहीं
सब बता के
So, at UG level, research has been introduced, and UG level research is going to play a very, very important role for the country. And in other universities also, in foreign countries also, UG level research is very important, and they are playing a very, very important role. So, just we will see here, what the at the UG level, if you are doing in fourth year, you are doing any research. So just to think, so one quote by David Bloor, which is so he told sociology could not be applied in a thorough-going way to scientific knowledge. It would mean that science could not scientifically know itself. So whatever thing we are doing, you have to see what's its impact, and how it has been developed, whether it has been followed the through process or not. And secondly, as a researcher, as a now it's fourth year program, so you should see research should tackle hard problems that matter to society. So today's now Government of India has taken a very good initiative for the AI in different domains, and there are many challenges in our society, in our country. How by using all those tools you can solve those problems. So how to make up a scale and how to develop your skill and how to solve those problems very efficiently of the society by using all these tools, all these tools. So in 2018, Government of India has launched a scheme. It's a national strategy for artificial intelligence, and also they have given a huge amount of money to different IITs, to different institutions, that how our students are going to develop their skills in the area of AI. And recently, in 2024, on 7th March, they have approved a India AI mission, and its purpose is to various domains, just like improve data quality, foster ingenious AI capabilities, attract top talent, support startups, risk capital, encourage industry collaborations, promote socially effective AI projects. So all these things are there, and they have a proper website also of this scheme. It's a India AI mission. So you can go through this website and you can find out different schemes, different projects offered by Government of India. And if you are in position to solve any problem, if you feel that our society, even Delhi, anybody has some problem, and if you are in position to solve that problem using AI tools, they will provide you fund also. There is also one, you heard about open4.gov.in? Any student, you heard about this? Open4.gov.in? So it's one initiative taken by the Government of India in 2014, through which any student can initiate any project, start any project, and through collaborations, some faculty members, some researchers, they can join this project, and that project can be developed. So it's a national e-governance district. So you can visit this open4.gov.in, and if any idea, it's a platform which is developed by the Government of India to make a collaboration of the faculty members, students, researchers, and any software developers who want to contribute to the country by solving some problem, by giving some solution, by solving some challenges faced by the society. Now I am going to discuss with you how machine learning is going to play a role in software evolution. How software evolve and what's the role of machine learning in terms of some predictions. So firstly I will discuss about how any open source software evolve, what's the role of different type of users, and I will show you how the development of open source software are going to be converted into a mathematical model. And after that, I will show you the various algorithms of machine learning that are being used in the development of open source software. So just to see here, it's an open source software development paradigm. We are users. We are using open source softwares, maybe Open Office. There are thousands of softwares. And there are two categories of users. One is passive and there is active users. So active are those who are really contributors. Passive are those who are simply using the software. And And then active users, again there are two categories, non-developer and the developer. So those who are using software, those who are reporting the bugs, those who are requesting for new features, those who are requesting for feature enhancements, they are simply categorized as non-developer. Again, there is developer. So developers are those who are reporting bugs, requesting for features enhancement, requesting for new features, and also writing code to fix those bugs. So now today, so many platforms are there. Sir, I told you about GitHub and all those things, where you can visit. What are the open source softwares are there?
हेलो
Their problems have been given, bugs are there, a request has been made,
कहाँ पे आऊँ
and you should try to write the code.
ये काम कर ले सॉल्व कर
You should try to write the code and try to fix those issues. That's the one area where as a computer science students you are supposed to do. And there is survey that in our country, mostly we are the passive users, even we are not the active users. So once you are using any software open source, some bugs are coming, we simply restart. But at least we should report the bugs. Also we should see that how we can enhance the software. So you can request for so many features. So at least you can be an active user. And I hope their honors students are very good. They can be a good contributor. They should try to fix those bugs. And also as a teacher, I am giving assignment to my students that don't, in terms of some questions and answers, only fix 5 bugs. And important thing is that you can feel that the software that has been developed, it is being used by some people, society, free of cost, without paying any money. So it's a one round, it's your good contribution once you are serving something for the society. So as a student, you can start this practice. And also you should visit Government of India Institute, openforce.gov.in, where you can register there. Also there are also different issues are there, bugs are there. You can fix those bugs. Your name will be highlighted there. And also you can start some new project also there. Through collaboration, some good project can be developed. So just to see, how any software develop, basically some open source software. So what we do basically, suppose software is very small, and we feel that, if some new features is required for the software, so we request for new features. What we do, some features are there, we request for enhancement. Some bugs are there, we try to fix those bugs. So all these are issues. Maybe it's a new bug, maybe it's a new feature, maybe it's a feature enhancements. All these are the issues. And once we fix those issues, we write patches, we write code to fix those issues. So there is some possibility that some errors will be generated. So once we go to fix any issue, some bugs will be generated. So by considering all these aspects here, this is only one equation I am showing you. So our software has this T number of issues at any given time T. So we are considering these 4 things: new feature introduction, feature improvement, bugs generated from new feature introduction, and bugs generated from feature improvements. So just I am trying to tell you that how you have a problem and how you can convert that problem into a mathematical form. So once it gets a mathematical shape, then you can do so many wonders. Means once that model is there, you have a data, you can validate it, you will get the unknown values of unknown parameters. This I will tell you, and you can get various applications. So what there is that the number of issues that are going to be fixed per unit of time is proportional to how much remaining. This is the basic idea. The rate at which the issues are going to fixed depend upon how many issues are remaining. And let us see that that the software has total a number of potential issues that can be fixed over a long run. And this XT, the total number of issues that is fixed up to time t. Now this, let's see here, there are four components. What is P? P is the rate at which new features are introduced. What is Q? The rate at which feature improvements are there. R is the rate at which bugs are generated from the introduction of new features. And S is the rate bugs are generated due to the feature improvements. So, just to see here that once new features are there, so for all the new features, we are not going to go for the feature enhancement. So a proportion of that, that's why I know in first equation it's P, but in the second component it's Q into XT by A. Means you are not going to create enhancement for all the new features, means a proportion of that. So by, it basically embody the open source software development, and once we solve this equation, we'll get a closed form, And we have a data, for any software, once you test your software, or open source softwares, we have all the data. There are so many properties are there. We have the data of bugs, data of new feature, data of feature enhancements, And once you apply this model, by normal applying the regression techniques, you can get the values of these unknown parameters. So total number of issues XT is known to you, T is known to you. So you can find the value of A, P, Q and RS. So once you find the value of A is equal to 200, it means total potential issues are 200. And if fixed, suppose XT is 100, it means 100 are remaining XT. And this P, Q and R and S, these are the rates that tell about your software, the rate at which new features are introduced, feature enhancements are taking place, or bugs are generated. So all these parameters you can get about your software. So these parameters will tell the quality control persons that which parameter is very high, what to do, how to employ the more people. By using all these parameters, you can very beautifully manage your software. So if you talk about any today, sir has actually told you that these almost techniques are not new. These techniques are very, very old. But today we have computational power, we have availability of data. So today there are so many sites are there. Even if you want to get data of Microsoft, Windows or MS Office, any proprietary softwares, you can't get data. But today's for the open source softwares, you can get the real data. No need to go for simulation, all these things. You can get the real data of different matrices and all those things. And for those, by taking the help of those data, you can develop some prediction models, and those models are going to play a role in those software evolution, in software development. So all these data are available with you, whether you talk about the source control repositories, we talk about the bug repositories, archive communication, development tasks, code repositories, the data are with you. Now, that's why there is one area emerged. It's known as MSR, mining software repositories. How to take the data, how to train your model on the data, and then how to predict the various attributes required for the development of that software. You are aware with all these kinds of bug reporting tools. Also, when you know that, as a user, you are reporting some issues. Maybe it may be a bug, maybe it may be a new feature, maybe it may be a feature enhancement. So, you can do all these things once you are an active user. And then it is going to be assigned to some person. So it's a bug assignment problem. So automatically how this bug is going to be assigned to which developer? Who is the right developer to fix this bug? Or who is the right developer to fix this issue? So it's a bug writing, it's a bug assignment problem. So at the same time, you are a user, at the same time, you are a developer, at the same time, you are a reporter also. So you can play a different role, different role. Just I'm giving you like one example, talk about any bug, you are aware with the bug. I mean, so these are the various attributes, and here the bug severity and priority play a very important role. How much severe that bug is. Once you reported that bug, and you mentioned that this is my bug description. So how severe that bug is. So in open source softwares, thousands of users are there, they are reporting bugs. So how do you know that how much severe that bug is? In case of priority, what should be the priority of that bug? So once you know the severity and priority of that bug, then you can manage the effort required to fix that bug very easily. And another important component is once you report any bug, so how much time this bug will take in fixing? It is called bug fix time. And fourth thing is, who is the right developer to whom this bug need to be assigned. So these are the areas your machine learning is beautifully applied. And in the industry, in the research domain, people are available. This is sort of the where you can get the bug IDs, product, component, status, resolution. Means all the data is available with you. You can get all these data, and also corresponding in the GitHub, you can get the code of all these components and the different patches written to fix those issues. You can get all the codes, who has written, what are the changes taken place, what durations. You can get all the data. And also you can get a kind of bug short descriptions, long descriptions. Means everything you can get on those bug tracking tools. And these are the basic normal traditional algorithms. So once you go to apply machine learning, in case of just I told you that for any bug, its bug description is given, bug summary is given, bug priority is given, bug severity is given, bug open date is given, bug fix date is given, bug status is given. So everything is given to you. Now what you need to do? You need to apply these algorithms, but I mean, just I'm telling you these names. You may be also aware with all these traditional algorithms of the machine learning. And then also, so those summaries will take the report of 10,000, 50,000, 1 lakhs reports. They contain huge features. Then again you have to apply the feature selection techniques, which features are important, So there are various algorithms for you for the feature selection. Again, there are different techniques of feature selection techniques. you can apply your bottom. And then the imbalance. Suppose I talk about bug 70. There are different 70 levels. There are some enhancements, there are some minor, there are some blocker, there are some critical. So different 70 levels are there. So if suppose your data is imbalanced, in one class data is less, other class data is more, then you have to go for handling those imbalance also. Then all those algorithms have some parameters. So how to tune those parameters? So there are various parameter techniques also. And then how to tune those parameters. So to build one model, you have to apply all these things. And suppose you are doing a empirical research, in that case you need to also apply a kind of combinations of all these things. We are developing some models, that consist of 70,000 classifiers. So we are considering all these their combinations. And suppose for any bug which is fixed, the status is fixed, and you know all the reports. So once some new bugs are coming, so for new bug, you can predict what should be the severity level of this bug, or what should be the priority level of that bug. And these are the data that you can easily collect. This is our NASA data set. So regarding the number of bug reports for the different severity levels. And once you extract those terms, once you give the bug summary, then you have to extract those terms. Suppose we are one NASA project data fits A, B, C, D, E. These are the number of features. These are the data for the open source software, Zero, Mozilla, and T. So you can collect all these data, with no problem at all. And this is a standard normal process, how to process the summary of your data. So you can take this bug summary or bug descriptions, you can take the bug priority, you can take who's the reporter. So you can take all those attributes to building the model. It's a pre-processing. It's a standard pre-processing.
अभी 15 मिनट में
So during pre-processing, we use TF, RDF, bag of words, word in bed is like 1 to 8, go for tag. Now today we are using BERT. So let's talk about BERT also. It takes quite actional. Just to write, I went to the bank to deposit money. They take on the bank of the river and relax. So in both sentences, the bank has different meaning. So it takes care of in both way, from left to right and right to left. So these are the various techniques which are being used to pre-process the data to find the exact features, the features which are going to play an important role in deciding the class level of the new bug report. So this thing we have done in one tool is a rapid minder. Rapid minder. It's a open source tool. So in the beginning, they were not, we were not in position to write some code, but now today they are also provide some features to write. We are also using the Python for running out these models. So it's a very easy model, rapid minder. In that, no need to write the code. They have the GUI, inbuilt GUI for different things. Like for all this process, transform the cases, filtering, tokenization, scaling words. For all the processes, they are boxes. You take the boxes, put together, and you can develop a model. It will waste time. Filter out the words.
ट्रेनिंग लगा दी मैंने बड़ा सब में इंग्लिश की। इसने कहा 10 बच्चे रखे हैं, 25 बच्चों के अटेंडेंस लिख के भेज दीजिए।
Some restrictions will include select term, class validation, selecting model, apply model, and the performance validation. So at the output you will get the result in terms of the performance metric. So where no need to write any code, no, you have to take the inbuilt functions, inbuilt graphical. Behind this there is a proper code, and behind that there is a mathematics also.
1:30 ब्रेक होगा, 2 बजे गायब हो जाएंगे। बात कर रहे सर से।
So in terms of
बाहर रखे रहता
when this performance metric like precision, recall, measure, all those things you can get all those.
हाँ उसका ये दुकानदार का फोन आया था 1:30 बजे करवा 10-15 मिनट आप कहाँ
Simply no. For once new bug is submitted by any user, any reporter, so you can tell what will be the priority level of severity level of that bug. Whether this bug is critical, this bug is minor, this bug is blocker, or this bug is normally a enhancement. You know, so you can classify the class level of that bug. Secondly, about the bug priority, how importance you have to give that bug. You know, I mean, in terms of priority, what the urgency to fix that bug. So in terms of priority also, in terms of the duplicate report also, in terms of the assigning a fixer also, so you can there are the classifiers.
आशीष भी सीएस पार्टी में कॉल करा रहे हैं।
Again, these are the data sets.
अरे
So
टीचर
we have
कॉल
collected this Eclipse open source project, and basically they form components of different versions, and it is given as per their priority. You can get the data, and they have given the priority level also. Once you report a bug, so you have to take only those bugs which have been fixed, and their priority has been given. So again you have the bug summary, bug descriptions, bug severity, bug reporter, and you can find out the priority of the bug. What's the priority of that bug? No? So let us see here that how machine learning algorithms are going to play an important role in the prediction of bug severity and the bug priority. Also, there is a class validation. And suppose you have a new project, for that new project, very less number of data is available. But if you want to train your model, you need to have a sufficient data. So what you can do, you can train your model, you can build your classifier on some other project, and you can just test it for some project. So in that case, you have to see that how two projects are similar. It's a concept of the cross project validation. So here also, suppose you have Eclipse project, you have Mozilla project. No? So you can build your model on Eclipse and you can run for the Mozilla in case of your number of data points are very less. And what you can do that you can take a combinations also. That one project has 10 components. Then you can take combinations of 1 to 10 or various permutation combinations. No? So you have to see that which combination is doing the best. No? So for any new bugs which are coming, you can easily predict their severity, priority, how much time this bug will take in fixing, or who can be the right fixer for that bug. This is the workflow for the also rapid binder. also read about the associable mining in data mining. So associable mining are also going to be applied in finding who can be the right fixer, who can rightly fix that bug by considering the various attributes. For example, here, bug fix time prediction will be associable mining. Like suppose severity is major, SI is steering, then bug fix time will be in the range of 0 to 19 days. So, for any software, these things are very, very important. That once bug is reported, that how much time this bug will take in fixing. Once you tell, once you predict that it can, then it can help to your product manager. It can also help in setting the release time of that software. So in that way, the SSL mining is not right here. It's a very beautiful application of association rule mining in finding the bug fix time. Another one application is suppose in the software there are 100 files and you are making changes, 100 changes in only one file. In another case, 1 million changes in each file. So tell me, in this case, the software will be more complex. बताओ भाई स्टूडेंट्स, आप लोग बताना चाहिए आप लोगों को। एक सॉफ्टवेयर है, उसमें 100 फाइलें हैं, आपको 100 चेंज आपने किया है। एक केस है, एक चेंजेस आपने 100 फाइल में कर दिया। दूसरा केस है 100 चेंज आपने एक फाइल में किया। किस केस में सॉफ्टवेयर ज्यादा कॉम्प्लेक्स होगा, अनसर्टेन होगा? बोलो भाई बच्चों। In one case you are changing 1 changes in all 100 files. In other case you are making all 100 changes in one file. So obviously that will be simpler once you are making all 100 changes in one file. Another case you are making 1 changes in all 100 files. So by taking this idea, once concept has emerged, the complexity of code changes, and by using the Seren's entropy, which has been developed in 1948, that has been applied very beautifully. It's a good code change process. How code changes are taking place. So, once you find any bug, you report. It's going to be trials, it's going to be assigned, it is going to be commit, and it is going to be stored in the source code. So in first case, it's easy to remember. In second case, it will be difficult to recall all those changes. It's perfectly good. Just to see here, what we do, you have a data of code changes, in a software, what changes have been done, in which file change has been done, and what time period. And suppose any software consists of these files, A, B, C, D file, and time is T1, T2, T3 time period. So what are you going to do? In a given time period, total number of changes and the changes in a particular file. So you can find the value of probability. So you can find the value of probability. So by using Seren's entropy minus pk log pk, you can find the entropy value of that particular file in that duration. So you can get an additional reports like the complexity of code changes of that file. So now this I am going to show you that how this entropy is going to be used with the machine learning in the prediction of bug severity or the bug priority or the bug fix time or who can be the right fixer. Once you get the value of probability, you can find out the value of entropy. So this pk is the probability of change occurrence and defined as the ratio of number of times kth file change during period and total number of changes for all files in that period. No? So you can measure the uncertainty, you can measure the complexity of that software.
कुछ तो कूपन रिफ्रेशमेंट के कूपन्स देंगे तो आई डोंट नो ट्राई सिस्टम
It's kind of the IEEE given weight for different severity levels. Water, critical, for the major, for the minor, and the
है तो हम पे
trivial.
it's the payoff nothing can pay off this
So let's
मजदूरी
look
है
at additional attributes.
भाई मजदूरी है भाई
So basic attributes are given to you. Once you report any bug summary is given, bug description is given, bug reporter is given, bug severity is given, bug priority is given, bug open date is given to you, and when that bug can be fixed. So all the data is with you, and we have an additional value that is the associated with software, that is the uncertainty in terms of the sentence entropy. So now we have an additional attributes. So once you are going to apply machine learning techniques, so don't think that you are going to apply on the additional data only. So just you can see that what additional features or what additional attributes also you can include to improve the performance of the model. So that should be a kind of the enhancement. Again, same question, you can use Python and you can use a rapid miner tool to classify. So you can apply all those algorithms, listing algorithms, and you can do some addition the data. You can add some new features, and you can develop a classifier. So in the same way, you can use for the severity, you can use for the priority, you can use for the bug fix time, you can use for the bug assigning, bug fixer, look at all those attributes. And also you can use a kind of the multi-modal approach, where you have the getting the data from various sources. Some may be a text, some may be an image, different type of data. And you can treat those data by different ways. It's a kind of the fusion. So you can go for the early fusion, late fusion, you can go for the hybrid fusions. So many things are available with you. Techniques are there, tools are there, processing power is there, data is there. It's up to you how you are using and how you are solving a real-time problem of the society. That's the only thing you are supposed to do. And for that, I told you already that one initiative, India AI Mission, and second, open4.gov.in. So you can read those sites and you can get so many things that you can take as an assignment. is the one here, I mean, in terms of the code smells, or code detecting. So it's it's a totally machine learning based software engineering. So it's not only a classical software engineering, it's a total application of machine learning in the software engineering. Now we are talking about the quantum software engineering and all this. So I'm not going to show you all these things. We have other areas to find the what are the different type of code smells are there and how to treat them and how to use those machine learning techniques. But only I want to tell you that this is one area where machine learning has been nowadays previously also very beautifully applied and they are giving the good results. And also company had developed a benchmark tool also for all these things. So it's a kind of the combination that you prepared, feature selection, imbalance, then parameter tuning, the kind of the various combinations. Suppose for feature selection there are 22 techniques we have taken, then imbalance 14, then classifier 17 and 5 means 22, 14, 5. A combination of all these things. We are considering to develop the various classifiers. It's a kind of empirical research. Which one will be better there and why it's will be better there, on what kind of data. And these are the various parameter tools. Once you go through any algorithm, you can get the various unknown parameters that you are required to. Okay, thank you so much. Yeah. So, any questions? Not only in case of software engineering, but this machine learning techniques you can apply in different domains also. For the flood control, to pollution, everywhere data is available with you, so you can develop those models. And but keep in mind that how our research, how our classifiers, how our models are going to solve some problem, some real challenge. That should be our basic objective. And you should feel that after passing out this college, you can feel that we have contributed something. Not in terms of getting degree, not in terms of only getting good marks, not in terms of only getting job, but in terms of that, we have done something which is being used by our society today, and that you can do it, because today's platforms are available for you. And the best platform is opensource.gov.in. You can visit those sites and you can get they are solving some society problems. तो आपको आगे बढ़ के कुछ करना चाहिए. ये कॉलेज की रैंकिंग आप बढ़िया है और ऐसे कुछ काम करेंगे तो उन पे आ जाएगा. So thank you so much.
Thank you so much, sir. Focus through the various activities which are involved in the software revolution and how machine learning can help it enhance or impact it positively. With this, we are ending this session, and I would like to thank our Chief Guest, Professor Praveen Chandra sir, once again, and our Chief Guest, Professor V.D. Singh. Sir, my dear colleagues, and all the volunteer students, all the participants, and some of our friends coming from different colleges. So उनका भी बहुत बहुत धन्यवाद. और all the students, आपको टोकन मिलेगा for your refreshment. at the gate, so please be disciplined in the line. हम next session के लिए मिलेंगे in 15-20 minutes. We are going to gather here at 1:45.